Hi, today we are going to discuss about linked list. First of all, we need to know what is a linked list. Linked list, it is made up of nodes, right? It is a collection of node. What is linked list? It is a data structure. More specifically, it is a linear data structure. What it is made up of? It is made up of nodes, many number of nodes. It can be one, right? It can be one, it can be many. So this is what linked list is. Why it is linear? Because the data, right, as I said, the data will be continuous. That means one after the other, the data will be in order. It is not continuous, it will be in order. Will it be continuous? Actually, it will not be continuous. Like the main difference between array and node is this. Imagine we have an array. Sorry, we have the array and it has some, let me draw it. Okay, we have the array and it has some data. Imagine it has some data, and these data are like 2, 3, 4, 1, 10, like this you can take. So it is a 32-bit system. That means int data will occupy 4 bytes of our memory. Okay, if imagine this starting from 100, so the next memory location will be 104, and the next memory location will be 108, and the next will be 112, right? It will be on 12. So this is what the array is. But when it comes to linked list, the memory locations are not continuous. It can be anywhere. So it will be in heap more specifically. See, there are the memory location. There is one memory location called heap memory location, and here we are going to store our nodes there by using malloc function in C, and new that is memory allocating operator called as new in C++. So we are going to discuss about this later. So let us see what is node. Right, I am going to clear everything. So imagine we have a node. This is a node. Imagine this is a node. It has two things. It has a data and it has a pointer. Right? It has a pointer. This is what node is. See, it has a data of, it can be of any type. It can be int, it can be float, it can be string, it can be anything. But the pointer should be of node type. That I am going to discuss later. Let us see how to bring this node under a single name. First of all, we know there is a inbuilt data types, what we can call inbuilt data type, that is called as a structure. What it does is it brings two data, it can bring many number of data types under a single name, right? I am going to create a structure now, struct struct. I am going to give the name of the structure as node. Then I can bring many number of data types under a single name. Imagine that here there is a node, right? We have data, it can be of any type. So that data I am going to specify here. For me, I need a int data type. So int data I have taken. After that, I have a pointer here, right? I have a pointer, it should be of node type. Means this pointer should be of the data type, the structure data type. It should be of that type. That is, see, that the node, when I create a structure of I am going to give it as that structure name as node, then that node can be used data type, that can be used as our data type, right? Just like int, float, string, we can use it as a data type. But one difference is it is made by us. That is it is not an inbuilt, that is made by us. That is why we are going to tell it as a user defined data types. Structures are the user defined data type that brings many data types under a single name. So that single name is node here. So I'm going to create the pointer of that, it's that of node type. So we have created, so this is a node, it is simply a node, it is a some diagram format, this is a code format I have created. And after that, it should see, it should be pointing the next node. How we are going to act, how we are going to create, imagine I have created a other node. Let me give the value of this node the data, as I said, let me give this as 2. What is the value of other node? Let me give it as a 3. Okay, it is my wish, I will give it as a 3. Okay, and it as a pointer. Okay, same like node what we created here. I'm going to, as I said, they are not continuous, means after this node this will not come in memory location. First of all, you have a doubt, you should have a doubt that why we are going to use this pointer. Our important thing is the data, right? These datas are the important thing. So why should we use pointer? It is used to connect the different nodes. See, I have a node here, other node here. How to connect this node? Since they are not continuous, means in memory location they are not continuous, I am going to connect through this pointer, this next pointer what I have taken. Actually, you can take it as any name you can give. This is a standard names that you are going to use in any platforms, in coding platforms. So I have taken it as a next, and this next is nothing but the pointer, and this pointer helps in connecting the other node. So I'm going to create a other node, right? I'm going to create an other node. Let me bring this here. Okay, we'll bring here. So I will create an other node. So I have created other node, and I will give it as a 4 because it is my wish. After that, I am going to connect to this node using this pointer. So imagine this is the last node that I have to create. What should be here? It should be a pointer, yeah, but it should be a null pointer. That means it should point, it should not point anywhere. I'll make it as a null. Why null? Because to specify that it is a last node. This is a last node. So to specify it, we are going to make it as a null. Or else we are not going to point any other data, right? Any node is not pointed after this node. So I am going to make it as a null. So this, I have created a linked list here. So this is usually created in heap, as I said. Let us code and understand. And before that, let me explain you one thing. See, creating the first node is different, and creating all other nodes are different. See, there are two methods I am going to use. First method, it is not method, it is actually two if-else statements. We are going to discuss about code afterwards. Let us see how actually this works. To create the first node, I am going to use the first method. Imagine like this. And to create all other nodes, I am going to use the next method. That's it. By using for loop, I am going to create this. I am going to add as many nodes as I can. So this is how it works. And even to delete or insert, we are going to use two different methods that I am going to discuss with you later. So this is about nodes. Let me code. Okay, I am using code blocks. So I am going to use a structure, struct struct node. I already typed int data. Then we have a node type, and it is called as next. Okay, I have made this one. See, again, let me tell you this one. I have created a node, right? This can be used as a data type, right? So what I am going to do is I am going to create a pointer of this node type outside the structure. Why? Because I have to create the node, right? Imagine I am going to take again. I have taken this code should come here. How to bring this? Okay, I brought this one here. Then we have a, I will create a pointer of node type. As I said, FIRS first. Let me take it as a first node. In order to create this first node, I am going to use this pointer first. So I have created this one. So after that, it is not physically created. That means it has no, like, where you are creating. In heap we are creating. So you know that how to create in heap. First, the pointer name is equal to new node. In C++ I am talking. I am talking about C++. In C you can use malloc function, and that is how we are going to create there. So let me discuss about the C++ version. So new node will create a node. How the node will look like? It will be looking like this, right? It will be looking like this. Since it is this pointer is of node type, that means it will have two things. It will have data. It will have the pointer of that own type. So I have in first, if I create a any variable, any pointer, if I give a memory, if I create a memory in heap, then memory will have two things. That is, one is data it will have, and other one is next pointer it should have, right? That is how it works. So this is so much important while creating the node. It is so much important to give new node. Many forget to write this line. Okay, let me go to code. So okay, now I'm going to ask the user how many node you need to create. He will tell me n, and after that I'm going to use the for loop. I is equal to 0, I less than n, I plus plus. Okay, I have a for loop. I am going to create n nodes. I am going to create another data like int type y. We are going to and I am going to ask the user to give the value for x. Why we are going to use the x? That is nothing but the data what I should fill in the node. These data, right? These data I am going to ask the user. So this x represent that one, right? I will ask the user why it should be int, because they have given this int, right? The data should be of int type. You can't mix other data types. Okay, I have given this thing, and in order to create a linked list, to create a node, I'm going to use the function called create. It is not an inbuilt function. I'm going to define this function up here. Then I'm going to pass x, that is the data I have to fill into that node. After that I'm going to pass I. Why? Because if I is equal to 0, that means I'm going to create the first node. At that time I'm going to use first method, right? To mention that one, I'm going to pass the I. Okay, after that I am going to create an void, because it don't return anything, but it creates a z node, create, create, then int x, int I am going to take. Okay, if I is equal to 0, that means it is a first node I am creating. So I need to take first, I will take the first pointer. So first of all we need to create node, right? The pointer for that nodes. For the pointer of type node, I have created in the previous, where it is, okay, here I have created, right? The same thing I have to do in the code also. I'm going to create let me call it as a first, and let me take a last, another pointer as last, which I'm going to discuss later, another pointer called t. So this t helps in adding up all other nodes. So the first pointer, it is solely used to create the first node, and the last pointer, it keeps the record, right? Let me show you how it works. I am passing here, I will create the first will be, let me clear everything, this is so much messier. Okay, so I have rubbed everything. It is so much satisfying to remove these things. Okay, I am going to delete this thing as well, because I don't need. Oh, okay. Deleted. Okay, we have fresh page here. Actually we could have scrolled down, right? Okay, okay, so I have a node here. So the first will be point, this is a first node, so this first node, first pointer will be pointing here. After that I'm going to create other node, right? I'm going to create the other node who will keep the using pointer t, as I said. So using this pointer I'm going to create another node, and all other nodes are created using the same pointer t. So we will keep a record like which was the previous node. For that we are going to use last. See, initially last will be pointing to the first node. When you create the first node, the first will be pointing to that node, and the last will also be pointing to that node. And when you create the next node, you will bring this last pointer, that is the last pointer, to this node. Like it will first connect, I am going to connect this node, and then I will bring this last here, right? Again this will come here and this will be gone here. Last, it will connect these two nodes and it will come to this last node, right? This is a last pointer. So if I create another node, if I create, at that time I am going to create using t, right? So it is all created, so we don't need any pointer, and pointer last will be in the previous node. So using t I have created the pointer one node, and using the last I'm going to connect the other node. Then I'm going to move this last to the next node. So this is how it works. Actually it may be simple while seeing this diagram, but it is somewhat difficult to understand in coding. So even I struggled while studying this, so you should practice more. So let me come to the coding. I will take the first pointer, I'll make it as a new node, means I have created a node in heap. And then first we'll have two things, one is data, the data will be x, and first will be having next, right? It will be have two things, one is it has two things, that is the data and next. That next will be null, because see, what if we have only single node, right? What if we have a single node, we don't have these nodes, we don't have, let me scroll, we have a single node. At that time the last node will be the same node, right? This will be only last node, this will be only first node. As I said, the last node should have null, so we need to make the first next as a null. So I will create it as a null. I have created that one. Then last, I said that last will be initially pointing to the first. Okay, then else, that means if it is not the first node, like at that time I'm going to use same thing, same what we did in for the first. I'm going to do same thing. I created the memory in heap, and t data will be x, and t next will be null as usual, as I said. Then what I do is last, we should observe this one, next will be t. What I did is I made last next, right? Last, as let me take other node, I created another node, and it has some data, it has some data, right? Let it be 2, it has 3, so this will be pointing here, right? This should point here. For that I will make last next. The initially last was pointing here, right? Even first was pointing here, right? FIRST first, REST first. Initially we did not add any connection, right? So last next means last next, that means next node. It should be what? T. This is a T. last, next is T. Then I have to move this last to the next node, right? I need to move. For that, what I am going to make? I am going to make last is equal to T. That I am going to do now. Then after that, last is equal to T. So I have moved, see, I have moved last to the T. Now I have last at this node. As I explained, this process will continue last, and again this process is iterative. So it will be happening like iterative means how many times I am going to run this loop, how that many nodes will be created in the same pattern. Then other thing, what we I have created the linked list. There is any error I am going to get. Okay, how to know whether I have created the linked list, right? For that I am going to display. For that I am going to use the function called display. I am going to pass first here. That means first. Actually, it is not necessary to pass. It is a global, right? So, but still, I will pass the pointer here. This will not return anything. It will display in the function itself. Display, again, it should be received as a pointer because I am sending the pointer of node type. So I am receiving it as a node type. So while printing, while I am going to take while P, right? I will explain this one. See, while P means while P isn't equal to NUL. That is what the meaning of while P, right? While why I am going to give this condition, because whenever our pointer reaches the null, whenever our pointer P, that is a in that function, that is the local variable, a local node, if it is going to be if it reaches the last thing, then it will be null, right? It will be null. So at that time I am going to stop. That is why I am going to use this while loop. So while P isn't equal to null, what I am going to do, I am going to print all the data of the P. So I will give some gap. Then I will push the pointer to the next. That means the pointer P will be first, right? It will be at first. So if I give P is equal to P next, it will move here. It will move here, right? For that reason, I am going to give P is equal to P next. I hope you understood. After that, it will be displayed. Let me run the code. Okay, I am going to give the number of data I need is 4, and the data are 1, 3, 5, 10. Like it should be printed. Yeah, we got the output as 1, 3, 5, 10. Let me give like 1. It will be 1. I need a single node of 1 of data 100. Also, I got this one. So it will happen for all the cases. All the base cases are covered here. So I have created and displayed the node. In the further videos, we are going to discuss about all the other thing what we can do for this. For this same, I am going to hold this same code. Then I am going to continue. Right? You can copy this. I will be giving this code in the description box. You can take there. You can copy paste and check. And one thing what I advise is you need to type. You try to type all the code by yourself by learning everything. It will be so much important, because linked list, it is not easy topic. It is for me. It was difficult for me to learn. After that, if you learn linked list, then stacks and queues and all other things will become easy. So thank you.